Hello enthusiast, this is Hex Trident and I'm Hex with you. Today we will start a tutorial called Portfolio Optimization Inside and this total course is called the Risk Optimization or Risk Measure, something like that. So this is the first tutorial you are gonna watch. For that I have to, in this tutorial we will optimize our portfolio on cryptocurrency coin and then we'll find out the efficient frontier for this and then we'll plot this with expected algorithm returns and expected risk. So let's dive into it. First of all, we have to load the required libraries. For that, I have some code in my desktop, so I'm just copy paste here. If you need this, I can share with you any time you like. This is called import pandas is simply because pandas is all gonna we need, and then this is numpy is also is a tool, so it's gonna need to analyze any data or something like that. This is warning, see if any warning arise that will ignore this letter is filtering ignore. And then Rixfolio leave Rixfolio, this is the library we will discuss here at most at briefly. And then import datetime to fix with to deal with the time step of the data for a downloaded. And then pd.option.display.float. This simple, this line means that here any number arise will arise in this format where up to 3 decimal places and percentage view up to 3 decimal places. Okay, this is our required library. It is just all, nothing else needed. Then we have to load the data. So as I said earlier, we want to analyze the crypto market. So I take 10 coins with the perspective, good or bad you can say, but nothing I can say here before any analyzation. Then I have to load the data. Here I take a data variable as a set, the empty set. Then for coin in the range len of coin set, I particularly this for loop particularly take each coin at a time, and then we enter this in a symbol variable and then add USDT, then doing the crypto data center plus symbol, something like that. This is all because my data is stored in the crypto data center folder, and the subfolder or the file name is the coin name and USDT, then CSV, all are lower cases. So that's all I did here, and then I load the chart.pd.read CSV symbol. That's all. Then I take the date and close time. That's all we needed to really analyze the data. All sorts of high, low, that's will we ignore here. And then what I did chart.close, and this close is as step load, because when you load from CSV data, most of the time the data variable could be in a text format or string format. That's the case you can arise. So I take this and convert the any data into float data, and then the chart that rename the close the coin section. Here we actually want a data data frame which is actually containing the coin name and the returns and this perspective dates. That's all we need from here. You can see in the next section on the next slice. So then we chart to rename it in the coin section dot coin, that's all, and chart the date. I particularly separate the date. This is also the time step, so I have to do this, and then chart the date. This is from date the time step, and int here 1000 is simply that when you have time step data, then you have to do some 1000 dividing and then find out what's going inside. If you don't have any time step, then you can just normally go through this date chart dates is equal to date. That's all you can do. And chart dot dates is equal to pd dot to date. এখন this also called that we have a time step, so we have to convert it to a date time or the date format. So here we do that chart dot date and day first is equal to true. Don't ignore the file date. That's all it said. Then chart dot index in place true. That's simple bit things. And df is chart ilog. This is called, this ignores all the others column I have in my library. Okay, then we get a try function, which is a data dot merge. We want to merge the data on how inner and on date we can merge, and in any expectation happens, then data goes to df. Now I have to do some little things also. First run this and this. Then if you want to look at the data, you can see here not simply data. You can see this data is in a date format. Date is increasing, and then VTC TRX, what's their percentage values is there, what is their values is there. Now we don't want that value, we want the squared returns, and that's all. So I do this coding. I have this in my PC, so I just copy paste it. You can pause your video and see what's going on. The scale return should be data coin PCT change. This change means that what's changing the day before, it's exactly entering here. So the day percentage change the day tomorrow and the day closing today, that's the change is here. And we are also saying the tails. This is the fact that this ADA coin is giving 4.79% decrease on 482025 and 13% increase on 492025. Okay, fine. Then there is the most inclusive part. We will estimate our portfolio. I have a details code here, so I just copy paste it. You can go through it. Is there some steps you can run? Step 1, create the portfolio object is a skill return. This is a skill return, which is must efficient in optimizing a profile portfolio. Then estimate expected returns. Expected return means how can I get from this investment. And covariance matrix. Covariance means how two coins stock market prices exactly reacting with each other. And historical data. Historical data means historical data is a past data, so I have to accumulate on this basis. Okay, then set optimization figure. Optimization model is a classic model, and RIX measures, and RV means variance, just variance measure. Simply, it's a tutorial one, so I am not dive into the basic of very deep in this section. In a further tutorial, we'll shape this out. Then object function. Object is a maximize Sharpe ratio, risk-free rate, risk aversion. Risk aversion factor used to utility objectives. We'll discuss that later. Just see what's happening here. Use historical scenarios true. Historical scenarios with scan occurs in a diverse matter. Sometimes they jump so much, sometimes they dip so much. That's catching this. And step 4 is run optimization. We'll have running this optimal weights portfolio optimization, and just we're following this model and just we're doing this as particular, and then we will display this and the words and transport it. Okay, let's see what's happening here. Okay, very good. We see Sharpe weights is 22.75% exact investment. Nothing is good here. Just TRX 26.82% and BTC Now we'll run efficient frontier. It's the most interesting and also the most important task here. So first, here we define the number of points and calculate the efficient frontier, how much point we want to calculate it, and generate the efficient frontier based on the selector optimization setup, which is actually this type of efficient frontier data portfolio efficient frontier. This is all we need. We know RM risk-free measures, points, risk-free rate, use historical scenarios. These will be the first few rows of the transparent frontier data. I think we will first transform it and transpose it and see what's happening over here. You see that in this sort of ratio our optimization process goes on and how much return we can get and what actually the risk return ratio should be and how much we can put in, how much risk can we put in our profile. Now plot a good function on this. Now set a custom level for the optimization portfolio on the front end. Custom level, which mean which level it should be. Just figure plotting. What's level we should do? Then nothing else. Then retrieve portfolio statistics. Here the most important part is retrieve how we get what's happening inside the model. That's actually say expected returns. Mean expected returns. How we get MU. This is a mu sign called mu covariance variance significance. This is all the mathematical terms. I can give you that if you comment below how and what you want to know, then I can share it with you. Then covariance matrix portfolio.conf, what we find there in our model here. Look, this portfolio.optimization, this is what we find there, and then we're applying it here. Okay, and asset returns, how much returns we get. Now we have to plot the efficient frontier along the optimized portfolio. Frontier plot, RP plot frontier, W frontier is equal to efficient frontier weights. This is called weight. W means weight, frontier. How much weights a frontier is actually holding. New expected returns, covariance matrix, return asset returns, risk measure. So risk measures MB is variance. We practically say that. And alpha 0.05 CMAP varieties as color map for the plot, and optimal weights, optimized portfolio weights, and a level portfolio level marker ester as the marker size, R is color, height, and weight. Now let me show what's this code, and I guess okay, great. You can see that efficient frontier mean standard deviation. This is where is the star lies in called. You get almost 100% returns with the risk is almost here is 85%, 84%. On 84% risk you can get 100% expected returns. So guys, this is all we discussed here. Catch up to the next video. Thanks to all.